In homework 4, we will be finding the standard form, which is the vertex form of your parabola, which enables us.
Jeff Miller.
This enables us to graph the parabola using the vertex and finding the intercepts. So the first thing through is to isolate your x's and make sure that a is equal to 1. Now we're going to complete the square. Oops. You're going to leave a space to complete the square. You're going to continue with your equation. Now because you added something, we have to subtract something. We take half of b, which is negative 4 divided by 2, so x minus 2 squared. We square 2 and put that here, and then we also put it here. We combine these like terms, and we have a parabola. Now, it lines up to your standard form. It also goes by your transformations. A is 1, it's positive, it opens up. The negative h is equal to negative 2, so your vertex is at 2, 5. And there's our transformation as well. It's a horizontal shift to the right and a vertical shift up 5. So your vertex is somewhere around here, 2, 5, and your parabola is opening up. Just how wide it goes helps us if we have a y-intercept. So we take our original 1 and we substitute in the zeros. And there is your intercept at 0, 9. So we can figure approximately where this parabola is going. Now to find your x-intercept, you're going to take your completed the square formula, set y equal to 0, and you're going to solve for x. So you're going to subtract 5, and then take the square root. And remember, you get a plus and minus. However, in our real number world, we cannot take the square root of a negative number. So we have no real x-intercepts. X-intercepts or zeros or solutions. Now you're increasing, decreasing, work the same as before. You are decreasing from negative infinity to 2, decreasing, and you are increasing from 2 to infinity. In number 2, when we group the x's, we notice we have a 3. We have to factor out the 3. Bring the 3 down, leave a space to complete the square, and this time when you do, we need to distribute that 3 in order for us to bring that out. Combine your like terms, and there's your vertex form. The 3 is opening up, it's positive. Your vertex has shifted left 4, down 3. There's your vertex. Your axis of symmetry cuts right through that h value. To find your intercept, come back to your original and take out the x's, and there y is equal to 45. Way, way up it's going to intersect. To find your zeros, come to your standard form, substitute in a 0 in for y, and solve. Remember, when you undo your square, you get a plus or minus, and the square root of 1 is 1. So take 1 and subtract 4, take negative 1 and subtract 4. These are your x-intercepts. It will help you get a grip on how wide that parabola needs to be sketched. In number 3, once you group your x's, you're going to factor out a negative 2. You're going to take half of negative 6, square it to get 9, and bring it out of the parentheses by distributing it. Be careful on this one. When you subtract a negative, it's like adding 18. So you get your standard form, pull out your vertex. This opens down because of the negative. It's got an intercept of negative 16 for the y, and find your zeros. Use your standard form. Otherwise, you're going to have to go back and factor and whatnot, but use your standard form. It's much easier. In number 4, when you group, you have a 1/2. When you factor out a 1/2, remember what you're doing. You're saying 1/2 x squared plus 2x. When you factor out this 1/2, you're essentially dividing both of these by 1/2. 1/2 divided by 1/2 is 1. There's your x squared. And 2 divided by 1/2 says 2. Divide, switch it over, and you get 4. So be careful when you divide by a fraction. And then leave your space for completing the square. Don't forget to factor that back in, distribute it, and subtract it out. Again, you have no real roots. You still have to solve this algebraically to show us that there are no real roots. In this last one, if you take a look at your transformations and you look at your core graph, you are at the 0, 0 here, and all you did was shift down 4. So when you shifted down 4, your x was still 0, and your vertex is 0, -4. Your 1/2 gives you a dilation. It spreads this a little bit more. So now we know our vertex, we know our axis of symmetry. You can find your intercepts the same way you always did. Just make sure that you reduce the radicals to lowest terms.